It's Monday morning, you've got two tickets in your queue, and they both relate to access issues to your S3 bucket. One comes from Sam, who is your backup analyst. He works in your company. And the other one is from Joe. Joe works in another company. He is an external auditor. And they both were able to access your S3 bucket last week, but they can't anymore. The only thing that changed was last week, security rolled out a change in the encryption keys from the default S3 encryption to customer managed keys, or CMK. Let's have a look at the issue. Here we're reproducing Sam's issue by making this AWS S3 command to copy from our source bucket, our demo bucket, this test backup file, and downloading it locally using the profile of backup analyst. And this is the error that he's getting. It's saying that this particular action of copying from the bucket down to my machine is not allowed because when it's performing the get object operation under the user backup analyst, it's trying to perform this action called KMS decrypt on a KMS resource. And this is the key name F4 AFE3. So let's have a look at our bucket. This is our demo bucket. And this is the default encryption settings. You can see the setting now is SSE KMS. Now, by default, when you first create an S3 bucket, this is the default setting. If you don't change anything out of the box, you get this SSE S3 setting. Now, that's already good because that means your objects or all of the files that you store in your S3 bucket is encrypted at rest. It uses the Amazon managed S3 bucket. It's free to use and it's fully managed. You don't have to worry about anything. We also have this option of using the key management service, or KMS for short, where you have to manage your own keys. So you create what is called a customer managed key because now we are the customers, are managing our own keys. So we create the keys, we delete the keys, we disable the keys, we manage things like access to it, as well as rotate the keys. So changing the keys as frequently as we need it to be. Here we need to define what KMS key that we want our bucket to use. The bucket key option here is to reduce your encryption costs. And it is well explained by this document. I'm not going to go into it, but just note that if you are setting the encryption to use KMS, enable this one. Otherwise, you're going to rack up your costs on calls to AWS KMS service. Looking at our test file, here we can see the encryption key that is used, and this conveniently gives us a hyperlink that when we click takes us directly to that customer managed key. Now on the left here, we are in the key management service console. We can see the two types of keys that I referred to earlier, where the default is the AWS managed key, this AWS /S3. And we can see there's key policies defined here, but there's no option for us to change anything because this is managed by AWS. Customer managed key, that's us. We are managing this key. And this gives us more control over the key on key creation, key disabling, key deletion, and we can rotate the keys. We can set how frequently we want it to happen, and we can set the key policy. Now for this key, I set the key policy to enable IAM user permissions, which means I'm delegating IAM service to manage the access to this particular KMS key. So you probably be wondering, why would someone want to use customer managed keys over AWS managed keys? Short answer is that This improves security. And why is that? Most security standards for data protection requires the ability to manage granular access, manage frequency of key rotation, be able to manage creation of keys and deletion and revocation of keys, which using the AWS managed key will not provide you with. And that's why in enterprises, especially those that need to comply with certain regulations like SOC 2, HIPAA, or PCI DSS, or even ISM, especially for protected level or and higher type of data, you'll need to use customer managed keys if you're in AWS. Just be mindful though with deleting of keys. If you have any object that's been encrypted with that particular key and you've deleted that key, then you won't be able to access that object anymore because that's by design, it's locked and it cannot be accessed unless you have the key. Now, to explain this and to make it clearer, let's look at this diagram. From the left, it shows Sam here is our identity. He's our DBA trying to access our S3 bucket here on the right, and he's not able to access it because there's two layers of security now that's been implemented. First is the S3 permission, which if we look at his permission set on the IAM user identity, we'll be able to see that he's got this get object permission, but then he doesn't have this KMS permission. And so we go to our IAM user console, drill down to our backup analyst. We can see here in the permissions section that he's only got S3 read-only access. We'll then create a policy that then allows him to access the KMS key. And the only action that he needs is to be able to decrypt it. That's because we're only reading and downloading the file. For example, if you need the ability to be able to upload files as well, then you need this particular generate data key action as well. But for our purpose, all we need to give it is that decrypt action. Now, in the resources section, we have the option to set it to all, but we want the least privilege. We'll scope the permission to the particular key. And we'll click this add ARN, copy the ARN from the key, give it a name, allow KMS, try the same command, and that now works. Let's delete that, clear our terminal. So, problem fix with SAM. Let's look at our next issue with our external auditor, Joe, who works in another company. We are now on the AWS IAM console of the external company. This account is named Sandbox03 here in the top right, and it ends in 3233. We've got our external analyst user. He's got the permission to assume the role in our other account, which is named cross account S3 read role. And this section here is the account ID. It ends in 3216, which is our main account. And that's the account that hosts the IAM role called cross account S3 read role, as well as the S3 bucket. So that's all we need to see on this end of the external company. Let's go back to our internal company, which is 3216. Let's open up IAM console and go to that cross account S3 read role. And we can see the permission here is allow that S3 read backups. So very similar to SAM, this role has the permissions to access the S3 bucket. Very importantly is this trust relationship, which says that this account ending in 3233, again, it's delegating it to it's delegating the permission or the trust relationship to be controlled by the IAM service of this account. Looking at our diagram gives us a better idea of what the issue is. This is the flow of access permissions to that S3 bucket on the right. So from the left is our auditor from an external company, account B. He's assuming the role of cross-account S3 read role. And this role has the get object permission. But because we've introduced KMS key now, this cross-account S3 read role will need that KMS decrypt action on the KMS key to be able to decrypt the data in the S3 bucket. So again, we have those two locks, two layers, but slightly different way of the permission flow because of Joe coming from an external account. So very, very similar to how we fixed the issue with Sam. All we need to do is manage this role instead of the IAM user with a permission that allows access to the KMS key. Maybe I should not have created it first before I showed you as proof that our external analyst is not able to download it. I'll delete it first. So here we're using our cross-account reader profile, doing exactly the same call to copy from that S3 bucket. And it's giving us a very, very similar error message of this KMS decrypt action on that same key. I'll quickly recreate the permission. Thing to note is that I'm doing it all on the console just to simplify and make it clear where the particular settings or where the particular configuration for managing the access permissions is set. When you go into production, you'd want to do this all in infrastructure as code. We'll rerun our command, and that gives us a successful download of that file from the S3 bucket. And that's it. We fixed Sam and Joe's access issues, which turned out to be quite a simple fix once you understand where that permission layer exists and how it all works together to be able to improve your security as well as to ensure that the proper access and the appropriate access level is configured. We've covered why we want to use KMS rather than the AWS managed key to encrypt our S3 bucket. We've also covered the cost as well as the potential risk of losing access to your file if you are not careful with deleting of your KMS keys. That's it for now. I hope that you now have a better understanding of how KMS works on your S3 bucket and how you can ensure that access is properly configured on your S3 bucket when it is encrypted or when it is set to be encrypted with KMS. See you next time.